Welcome everyone, I'm super excited because today we'll create a full stack application using a very original stack. Let's check it out. On the front end, Rust as a core programming language, Web Assembly to run Rust in the browser, we'll use Yew, which is a new Rust front-end framework, and Trunk, which is a tool to run these Yew applications. We'll use the trunk serve command. And last but not least, Tailwind CSS. This is optional, but you might like it or not. On the backend, we will use Rocket, which is a web framework for the backend in Rust. We'll use CRUD REST APIs, of course. Rust as a core programming language, of course. For the database, we will use Postgres, of course, running in a Docker container. I love this stack, all the code will be available on GitHub, so no worries, you can check the whole project and the whole step-by-step process to create it from the database, then backend and then frontend as soon as the video will start. Let's get started! Let's create our full stack Rust application. First of all, let's create a directory. We step into that directory and then we open this with any IDE we want, for example VS Code. We initialize a Git repository. And then we'll start by creating the database. We create a compose.yml file. We'll use Docker to run the database, of course. We define some services, but we'll have just one service. DB, container name DB, image Postgres 12, ports 5432, environment, something you should never do, Postgres user, password, and DB, all three of them as Postgres. As a volume to persist data, a volume called pgdata with the default folder, and then we need to define this volume, pgdata curly brackets. And then just docker compose up, and this should spin up this database locally. You can see here, database is ready to accept connections. Let's try it out. Docker ps-a, we can see the database here up and running. This is promising. Docker exec-it db psql-u postgres, and we are inside the Postgres container. \dt did not find any relations, and it is absolutely normal. We'll create a table in this tutorial, no worries. Now let's start creating the backend service. Cargo new backend with the option --vcs none. This will not create a Git repository because we already have one in the root folder. We'll create two projects in this root directory. Now let's define some dependencies. We need Rocket, a Rust web framework for backend applications, version 0.5 with features JSON, then third for serialization and deserialization, and then third underscore JSON because we want to send JSON objects in HTTP calls. Tokyo is used for asynchronous operations in Rust, and then Tokyo Postgres because we want to connect this application to the Postgres database. And also Rocket Cores because we don't want to have CORS issues. We'll have two separate applications, one for the backend and one for the front end. In this case, we'll have applications both on this machine, but maybe we want to deploy them somewhere, so we should implement these CORS functionalities. Let's open the main.rs file and let's start creating this backend service. Macro use extern create rocket because we want to use the rocket annotations, and then the imports. Use rocket third deserialize and serialize, also JSON. Use rocket state response status custom and HTTP status. Use Tokyo underscore Postgres client and not TLS. Last but not least, use Rocket CORS. CORS options, allowed origins, and we are done with the imports. We need to define a struct with these attributes: serialize, deserialize, and clone. Struct user with an ID, name, and email. But the ID will not be an integer, but I want this to be an option, because when I create a user, I don't want to provide the ID. I want the ID to be automatically assigned by the system. We'll see this when we will test our application, of course. Now, let's start creating some endpoints and their handle. Let's make one for a post request on /API/users with a user as data, in the body of the request of course, async fn add user as parameters con, which stands for connection, state client, a user in JSON format, and that it will use the struct user, and this will return a result, a JSON array of a vector of users or a custom string, in case we'll have an error. That's right, the body of the function will execute a SQL query with a connection, this SQL query, and then will provide a username and user email dot await with the question mark operator, and then at the end we'll also get all the users using the connection and dot await again. Let's create this execute query function. As parameters, we need a client, a query, parameters for that query, and then this will return a result, u64, or a custom string. And then in the body, we use the client to execute the query. Let's create a function to get all the users, get /API/users, async fn get users as parameters. This is similar to the previous one. Con at state, we are using the reference here, client, and then this will return a result of what? This might return a JSON of a vector of users, so this will return a JSON array of users, or it will return a custom string, in this case the error. And this will call a function getUsers from DB con.await.map.json. Let's write this function, async fn getUsers from DB client, that will return a result vector of users or custom string. Curly brackets, let users equal client.query the statement and parameters. As a statement, we have the SQL query. We select the ID, name, and email from users.await, or we map to error, and then we iterate, and at the end, we map all the rows together for the users with an ID, name, and email. And at the end, we collect them inside a vector of users. We return OK users. And of course, this has to be capital back. Let's create a function to update users, put /API/users/ID with a body, async fn update user with a connection, an ID, and user, and then it will return a JSON of vector of users or custom string, and we execute a query with a connection, SQL query, with parameters username, user email, and ID, dot await with a question mark operator, and at the end we return the users. The last one to complete the CRUD operations is the delete one, /API/users/ID. Async fn delete user with again connection of type @state, client, and ID, the ID that we want to remove. And this will return a result. This will be a bit different, with just the status in this case, or again a custom string. Execute query con delete from users, where ID equal $1, we pass the ID, dot await, and at the end we return OK with the status. We are almost done with the backend. We just need the main function. We use the rocket macro here, launch, async fn rocket, let client and connection equal Tokyo Postgres connect to host localhost, user Postgres, password Postgres, db name Postgres, not.ls, .await.expect. In case we get an error, we'll return this custom error message. We try to establish a connection. In case we fail, we'll return an error. And then something important, we need to create the table if it doesn't exist. Client.execute, we write the SQL query like this, without parameters, and then .await.expect in case we'll have an error. Failed to create table, let course equal course options. We use the default function here, allowed origins all to course expected in case something wrong happens with course. Rocket build.manage client, we mount all the routes, add user, get users, update user, delete user, we attach course, close parenthesis, and we're done. We step into the backend folder, cargo run. This usually takes a while the first time we compile it. It worked, but we have a strange warning. Let me just remove this import. Probably I made some mistakes while typing. Let's run this again. And this time it seems that it worked. I really like the colors that Rocket provides. And if we go on localhost port 8000, we have a 404 not found. The requested resource could not be found. But this is an error message by Rocket, so this doesn't mean that it worked. We have an error here because we have no handle for the default route. So we can go on the URL and add /API/users. And in this case we see an empty array. This is really promising. If we want to create a user, we need to make a post request. So first of all, let's open Postman. Let's try again a get request /API/users, hit send, and indeed we see that we have an empty array here. But now that we are using Postman, we can make a post request here with a body, and let's create a new user. Name AAA, email aaa@mail.com. Let's hit send, and yes, we just created our first user, and as you can see, the system provided a serial ID. User has ID number 1. We don't need to provide an ID when we create a user, of course. Let's create another user, bbb, sorry I'm not creative today, as email bbb@mail.com, and we see that we have a second user. Let's create a third one, ccc@mail.com, and we have 3 users. Let's try to update a user, making a put request on /API/users/2. For example, we want to modify the user number 2, and we want to change the name with Francesco, my name, and email francesco@mail.com. Check the ID2 user. If we hit send, we have the updated user there. The last endpoint we need to test is the delete one. So let's make a delete request on /API/users/1. We want to delete the user with ID 1. We don't get the list of users back, but that's okay. Let's make a get request again, and indeed we have just the users with ID 2 and 3. We can see that this is consistent if we make a request on the browser, but let's try this also directly in the Postgres container. We can see that now we have the users table, select star from users, and indeed we see CCC and Francesco. Now let's create the front end. The interesting part of this video is that we are creating the front end using a Rust front-end framework. We are using Yew, a Rust front-end framework inspired by React. So if you know React, you will find the code sort of familiar. But to use it, we need to install a couple of things, because we need to compile the Rust code with Wasm, so we'll be able to run this on the front end. This is a very fascinating technology. How can we do this? If this is the first time that you write Rust code on the front end, you need to write this command: rust app target add wasm 32-unknown-unknown. This command might change in the future. In this case, I already have that, so that was fast for me. And we also need something to run this code, maybe locally. A nice tool we can use, it's called trunk. cargo install trunk. This is installed globally on your machine. In my case, it's already installed. You can try trunk -- version to be sure that you have it installed. We'll use it later, but first we need to create the front-end application. Cargo new front-end -- VCS known. We don't want a Git repository inside a Git repository. Dependencies. Yew version 0.21, Wasm bindgen, Web SYS, Glue. This is similar to Axios. If you are a JavaScript developer, we'll use this to make HTTP requests from the front end. Wasm bindgen futures, and again third, because we want to serialize and deserialize JSON objects also, of course, in the front end. Let's create an Index.html file in the frontend folder. I will go fast here. Doctype HTML, an HTML element. Let's remove a couple of lines here. We don't need this one. We don't need this and this. Let's add meta chart set and meta name viewport. I want to change the title with Yew plus Tailwind. Yes, we'll use Tailwind also in this Rust frontend project. In the body, we create a single div with ID equal up, script of type module. We import init pkg frontend.js and then init. Let's go in the main.rs file in the frontend folder. Let's make some imports. Use Yew prelude, use third deserialize and serialize, use glue net http request, use wasm bindgen underscore futures, spawn local. We need a struct with this attribute, derive, serialize, deserialize, clone and debug, struct user with an ID, a name and an email. And now fn main Yew renderer up new dot render. Let's start creating this application. This will look like React, as I already said. Function component up, and inside this fn up parenthesis that returns HTML curly brackets, let user underscore state equal use underscore state, and this is to initialize an empty user for the form. Empty, empty, and none. Let message equal use state empty string dot toString. Let users equal, this is the list of the current users, use underscore state vec new. We initialize the users in a vector. This of course will fetch the database. And then let get users equal to curly brackets, let users equal users.clone, let message equal message.clone, and then we need a callback from move pipe underscore pipe. We are using closures here, and then let users equal users.clone, let message equal message.clone, spawn local async move curly brackets, and then a match statement, request get 127.0.0.1 colon 8000/API/users dot send parenthesis dot await. And then in case of OK and we get a response, if the response is OK, we define fetched users and then users.set fetched users. Otherwise, we set a message on the UI failed to fetch users. Another function, let create user equal curly brackets, let user underscore state equal user underscore state dot clone, let message equal message dot clone, let get underscore users equal get underscore users dot clone. And then another callback from move curly brackets, let name, email, and underscore, we will not pass the ID, we defer the user underscore state dot clone, let message equal message dot clone, let get users equal get users dot clone, and again spawn local async move let user underscore data equal third underscore JSON name and email. This is to create a new user from the UI, and then let response equal request post http://127.0.0.1:8000/API/users. We need to add a header of content type application JSON .body userdata.toString and then .send.await. We are sending this post request. And then match response. I'm a huge fan of the match statement. And we have something very similar to the previous one. We set the message as user created successfully and we get users in case of OK, otherwise we return an error. And at the end we reset the state of the forms on the UI after we create the user. Let update user equal curly brackets, let user underscore state equal user state.clone, let message equal message.clone, let get users equal get users.clone, callback from move pipe underscore pipe, let name email and editing user ID equal user state.clone, let user state equal user state.clone, let message equal message.clone, let get users equal get users.clone, and then if let some ID equal editing user ID spawn local async move let response equal request put format http://127.0.0.1:1000/API/users/curly brackets. For the ID, we still have a header with content type application JSON, a body with third JSON to string with the ID, name, and email, .unwrap, .send.await. And then another match statement with a response is very similar to the previous function. In case of OK, we return user updated successfully and we get all the users, otherwise we set an error message, and at the end we reset the forms. So if we update a user successfully, you reset the name and email in the form on the UI. Last function, let delete user equal curly brackets, let message equal message.clone, let get users equal get users.clone, another callback function. This is a bit different from move, and we use the closure with ID i32, let message equal message.clone, let get users equal get users.clone, and again spawn local, let response equal request delete format with the same address /API/users/curly brackets for the ID, .send.await, match response again. In case of OK, we'll set the message as user deleted successfully, otherwise we'll set the message as failed to delete user. One more function, let edit user, let user state equal user state.clone, let users equal users.clone, another callback from move with the ID, if let some user equal users.iter parenthesis dot find parenthesis u.id equal ID, and then user state.set username.clone user email.clone and some ID. This is to set the form when we'll hit the edit button. We will see an example soon, no worries. And now the HTML part. This is very similar to React. We will go fast here. Curly brackets, and we can use Tailwind here. So div with class container mx auto p4. We have this h1. This is the title of the page. Another div with the input for the name, an input for the email. Of course, we will not provide the ID. And then a button to create or update users, a message for the state of the application, and another button to fetch the list of the users. An h2 with user list, and then a list of users. We can write here Rust code inside this sort of HTML element. It's very fascinating. For users.iter.map with a closure, let user ID equal user.id, and then we have again some HTML, and this will be the custom item for each user. We will see this soon. I made a mistake here. This h1 should be here on line 135, my bad. And then let's step into the frontend folder, cargo build -- target wasm32 unknown to build the Wasm package. Let's see if we get any mistake. And we have an error. Okay, that's easy to fix. Line 37, I forgot to add let user state equal user state.clone. Let's try again. And it worked. Now we need to serve this project, and we can use a trunk serve. We can click here. That's very handy. Okay. I think I forgot to add a label on the button there. So let's add that. Okay, that's better. Let's try to fetch the user list. Failed. Okay, the error message is correctly displayed. The problem here is that I forgot to add on line 19 http:// and now if we fetch the users, wow, we have the current user list that is already in the database. Let's create a new user, yes@mail.com, create a user, and yes, it worked. We can also see response on the server. Let's try with Postman, and indeed we can see the new user. So this is consistent. I want to try the other functionalities. For example, we can edit the user with ID 3, click edit, and now we can use the same forms. Let's change this to subscribe and subscribe at mail, click update user, and yes, indeed this has been updated successfully. You can also see the put request here in the backend. Let's try to delete a user, for example this one, deleted, and let's add a last user. Last at mail, create user, okay. Let's try with Postman. Yes, it worked. Let's try on the browser, localhost 8000/API/users, this is the backend, and yes, we can see the user. The last test is to try this directly in the Postgres container, and indeed we can see the current list of users. Well done!